So here we are in the Unity editor. I am using the default layout at the moment, the default user interface layout. We're going to be changing that and I'll show you how to do that in an upcoming video. But what I want to do here is to give you a glimpse of the future. What I have open in front of me is the completed project. That is, after completing all the modules of this course, we will finally arrive at this project here, which is a box pushing puzzle game. We're going to be creating two levels. You can see them here, scene 00 and scene 01. This is the first level that we have in front of us here. And what I want to do is to show you and give you a guided tour of the project that we are going to be making here. So what I'm going to do is I'm going to press the play button on the toolbar just to begin playback. And you can see that we have some music playing in the background. Now we have our character here in the scene. Actually, what I'm going to do, I'm just going to stop playback. And I'm going to maximize the scene viewport. So I'm going to hover the mouse cursor over here, over the scene view, and press spacebar on the keyboard to maximize that view. And I'm going to play this in full screen so that we can just see things a lot more clearly. So I'm going to press the play button on the toolbar, and you can see that I'm controlling the character here. Actually, notice straight away I've made the mistake of being active in the scene viewport. I just want to stop playback, come out of that, and switch over to the game tab. When you play the game in full screen, make sure that you have the game tab active and not the scene tab. So here we are on the game tab. I'm going to just maximize that just to get a better view here. So let's come up here to the toolbar, press the play button like so, and you can see we have our character here. Now I'm controlling this character. I can use the W, S, A and D keys on the keyboard to rotate this character and look around the level. Now the objective of this puzzle game is to push these boxes here onto the 4 destination points in the level. In this level we have 4 destination points, but other levels could have more, and indeed the second level does, as we'll see in a moment. Now the key rule in this puzzle game is that you can only push boxes. You cannot pull them. So let's just walk over to this side of the level, turn around here, and I'm just going to push this box forwards onto the destination point. And that box now is securely in place, and that is where it should be on its destination. But if I move over to this side of the level and I push this box forwards into this corner, I have now made the game unwinnable, because I cannot pull this box at all. There's no way I can get this box out of this corner. So now I cannot complete this level because I can never get this box onto its destination. So what I'm going to do is press the R key on the keyboard, and that just resets the level back to the beginning so that I can try again. And that really is the main objective of this puzzle game, to put these boxes onto their destination points. And that is the objective of each and every level. But there's a lot going on in this game. First of all, you can see here we've got an animated character and it's in motion. And when I push a box, you can see that it plays a box pushing animation, like so. We've got some basic physics going on. We've also got collision detection. I can't walk through these walls, for example. We've got a particle system here for the fire torches on the wall. We've got illumination in the level. We've also got some dynamic illumination for the moving character models. And we've got inverse kinematics that's going on also. And we also have load and save game functionality that we'll see much later in the course. So let's complete this level. I'm just going to push this box here onto its destination point. Push this box forwards like so. Move over here. Notice also we've got a third-person chase view camera that smoothly rotates and follows our character model. So let's move over to this part of the level here and push this box forwards onto its destination. That's the third box in place. And finally, we're going to put the final box onto its destination point. And when we do this, the game is going to change to the next level. So let's take a look at that. Push that box onto here, level complete, and then suddenly we're now in the second level where we have to move these boxes onto their destination points over on this side of the level. So we've got quite a lot going on here. It's much more complicated than it first appears, at least, and over the course of this course we're going to be really getting in depth and digging down deep to see how this game works. So with that said, let's move on. So now let's start at the very beginning, because that's a very good place to start. What we're going to do now is, from the very beginning, we're going to be creating our box pushing puzzle game. And the first step in creating any Unity game is to create a new project. And I'm here at the Unity Project Setup Wizard for creating new projects, and you can access this by simply choosing File, New from the application menu. So here I'm going to choose the project location for my project, the folder where we're going to be storing all of the files. I've specified this on my computer, but please go ahead and follow along with me and create this in a folder, any folder that you want to put your project in. Now before clicking the Create button from the dialog here, I'm going to be importing some packages in this project that we're going to be using later along the line. In particular, I'm going to enable the image effects package, which is a pro-only feature. So if you don't have the professional version of Unity, then you can't import the image effects package. But don't worry too much. This adds a bit of extra pizzazz and glam to our games and is not essential. I'm also going to be importing the particles package, so I'm going to enable that checkbox and then choose the Create button from the dialog here to go ahead and generate a new project. So Unity goes ahead and whizzes away and decompresses all of its different packages and imports them into a new project. So once the project has been generated, we end up here in the Unity editor looking at a completely blank new project that we have here. We have an empty scene in front of us. We have these folders here which were automatically generated when Unity imported the packages we selected. These are part of the image effects and the particles packages. And before going any further, what I want to do is to configure the user interface. Just to tweak it a little bit. I'm happy with how most of it looks. This user interface layout here is part of the default layout. You can access that by choosing Layout and selecting Default from the context menu, and that gives you this default layout that we have here. I'm happy with most of this, but we're going to be using some features that's going to really make it a bit helpful if I can just tweak it just a little bit. In particular, we're going to be using light mapping and the mechanism animation system. And what I want to do is to bring up those editor windows and to dock it into the interface at a convenient place. So let's begin by opening up the mechanism animator window by choosing Window from the menu here and choosing Animator. Now this immediately is docked already into the interface. You can see here we have the Scene tab, the Game tab, and now we have the Animator tab. And it just so happens that this is where I want it to be, but perhaps your window doesn't begin here. For example, let me just grab this tab by clicking and dragging and just pulling it out here. Maybe your tab appears initially as a free floating window like this, or you can easily just dock it into this interface just by clicking and dragging the tab and just dragging it here into the user interface to get these three tabs here. So I'm going to leave the Animator tab right here. Let's just switch back to the Scene tab. And I'm just going to select Window and bring up the Light Mapper window. So you can see that here under Window Light Mapping, which brings up the light mapping window. And I'm going to drag and dock this over here next to the object inspector. So we have the inspector and light mapping together on separate tabs in this area of the interface. So I'm happy with this the arrangement that we have here. I'm going to just save this layout by clicking on Layout and choosing Save Layout. I'm going to call this layout Box Pushing and choose Save here on the dialog. You can see now it's listed as the box pushing layout, and we have that layout set up here. So we have that box pushing layout now. We can select that from the default layouts. So there we've configured the user interface. What I want to do next is to consider importing assets and configuring them. In the preceding movie, we created a project and configured the user interface. And what I want to do now is to import the assets for our game. To do that, I'm just going to bring in a Windows Explorer window that we have here. Let's just bring this into view. And we have this window here. These files are included in the course companion files that you can find in the Assets to Import folder. And they include all the assets we're going to be using for our project. We have here an audio folder which contains some music and sound effects tracks for the game. Here we have a music track, and here is a sound effects file that will play when the level is completed. We also have some mesh files that span across these three folders here, the character, environment and props folders. Let's just take a look at these here. You'll see that we have a character mesh which includes a complete rigged and animated character that's going to be the player character for the game. You'll notice that the file is in the FBX format, and I want just to say just a little bit about that right now. Now, Unity supports a range of mesh files. It includes, for example, the native Maya files, which includes the MA and MB files, or 3ds Max files, which includes Max scenes, and the Blender files, which is the .blend file extension. Now, although Unity does support those files, you have to have the software, the 3D software, installed on your computer to import them. So if you want to import a Maya file, for example, an MA or an MB file, you need to have Maya on your computer when you do the importing in Unity. Now that really is not very useful, particularly if you're giving your project to somebody that doesn't have that 3D software. So instead what you can do, and what I recommend you do for your own meshes, is to use the exported formats. And that includes an FBX file or a collada file which has the extension of DAE. So I recommend that when you create the meshes for your games, you use either the FBX format or the DAE format. Both of those are really great formats to use. So I'm going to get started at importing the textures for our game, and they're all included inside this folder. We have the character textures, environment textures, and some GUI textures. I'm going to import them all together simply by just dragging and dropping this textures folder here into the Unity project panel and releasing my mouse. And Unity goes ahead and imports those files automatically for me straight away like so. So it goes ahead and does what it needs to do. And there we have it, all in one batch. Those textures have been imported into our project. I'm going to create a new folder here in the project panel by right-clicking and choosing Create and Folder from the context menu. I'm going to name this Meshes, and then I'm going to bring back my Explorer window. Let's just open up the Meshes folder by double-clicking on it and just bring back the Assets folder. I'm going to drag and drop the character mesh into the project panel, and it imports that character mesh. I'm going to do the same for the environment and prop meshes. I'm going to drag and drop those into Unity as well. And now we've imported all of our mesh files. Just going to go back over here and bring up Windows Explorer again and drag and drop the audio files into the Unity project to import the audio files as well. And there, in just one operation, I've gone ahead and imported all the files we need. Next, we're going to get started at configuring these assets inside the Unity editor. Now we've imported all the necessary assets into the project, and I want to proceed further now by configuring them. Let's start by configuring the textures that we've imported. To do that, I'm just going to double click on the textures folder that you can see here in the project panel. Let's just open up these textures, and we have a variety of different textures. If I open up the character textures folder, you can see that we've got a range of textures here that are going to be used for our rigged character. We're going to be dealing with the character and its assets in a later section of the course, but you can see those textures previewed here in the preview panel inside the object inspector. So I'm just going to make that a bit larger and just increase the size of the preview window here, just so that you can see those just a little bit better. So I'm just going to move back over here to the textures folder and take a look at the environment textures, which we're going to be using. There are 3 of them here. We have the standard environment texture, which you can see contains texture data for our boxes, for our doors, our floors, and our walls. You'll notice that all of this texture data is bundled together into one texture. This is called an atlas texture because all these different objects, our boxes, our doors, our floors, and our walls, all share their texture data in the same image. And this is a really great way to boost the performance of your game. You'll notice here that the dimensions of this texture are listed as 1024 by 1024, and that actually does not represent the true size of the image file. In fact, these image files are 4096 by 4096, which is a huge texture. But I'm going to increase the size to that dimension there. Just switch to the default tab and just change the max size for the texture from 1024 by 4096. We can always downsize the texture through any of these lower sizes if we want to, if we find that this texture size is slowing down the performance of our game. I'm going to click apply there to accept those changes. Now if I want to, for example, apply different sizes to this texture across different platforms, let's say we're going to also make the game for Android, for example, I can just switch to the Android tab and choose Override for Android and choose a different size, which means that if we build the game for the Android platform, it will use these platform-specific settings. And that really is a very great and easy way to make your game cross-platform and just build games really just at the touch of a button by choosing different sizes for those platforms. I'm going to switch back to the default tab here where we can see our texture size. And I'm going to increase the size for the other textures. Just choose apply there for that texture. Notice that this is the props texture. This is for the various props in our game. We've got a table texture here, the side of a bookcase, for example, the grey stone for a pillar. and we've got some textures here for a fiery torch on the wall. We're going to be seeing all of these objects later in the game. We've also got a normal map for the game here. I'm going to switch this texture type from texture to normal to indicate that it's a normal map, and I'm going to change the size from 1024 up to 4096 and choose apply there. And in that operation we have now configured all three of the textures for our project. So now let's move on to meshes. So to examine the imported meshes, let's switch back to the assets folder here and open up the meshes folder, and you can see we have character, environment and props. We're going to be leaving the character mesh into a later section of the course. So right now I'm just going to focus on the environment and prop meshes. Let's open up the environment folder, and you can see that we have 4 different files for the environment. These are modular meshes, which means that we're going to be fitting them together to assemble a complete level. The key thing I want to talk about here is the scale factor for the mesh. If I drag and drop this mesh into the scene, you can see that, well, we can hardly see it at all. It is absolutely tiny. You can see it's in the level because we can see it listed in the hierarchy panel here, but we don't see any visual indication that it's in the level at all, and that's because it's absolutely tiny. So let's just select this mesh and delete it and move back to these mesh files, and I'm going to select them all because we can adjust their properties in a batch here. So you can see that the scale factor is 0.01. Now this sometimes might be what you want, but it is certainly not in our case. Generally it's a good idea to have your scale factor at a nice round number of 1. So I'm going to change that to 1 here, which indicates that they should be imported at their default sizes that was given to them in the 3D modeling software. So I'm going to set this to 1 and scroll down and choose apply, like so. And now when I drag and drop this mesh into the scene, you can see now we have a much more reasonable size. This is looking much better in our scene viewport. So I'm just going to delete this mesh here. We're going to be building the level in a later section. And I'm going to do the same for the prop meshes that we have. You can see we've got a chair mesh here, we've got a pillar mesh here, a bookcase, a table, and a torch, and these are going to be really used as decoration for our environments. But like the other meshes, they're imported at a scale of 0.01, so I'm going to select all of these meshes and choose the scale factor of 1, scroll down and choose apply, and there we have configured all of our meshes for our game. Let's just jump back over here to the assets and go into the audio folder, and you see we have our 2 audio files. We can just click the play button here on the preview panel to preview those soundtracks, but I'm going to leave them as they are for the moment. You'll notice that both sounds, however, have the 3D sound option enabled, and that is not applicable to these sounds in this case. We have a loopable music track and a sound effect that should play when the level is completed. But none of these sounds really exist in the 3D space of our level. They're simply intended to play to add atmosphere, and we don't really care about where they are situated in the world because they're not in a particular location. So we can select both of these sound effects. Actually, no, we can't. Multi-editing is not supported for sound effects. So we're going to have to select them individually and disable the 3D sound checkbox. We want these to be 2D sounds. Now for the music, I'm going to select this, and I'm going to change this from native WAV to compressed OGG Vorbis to make sure that this sound is compressed in memory, and I'm going to press the apply button, and that will compress the soundtrack using the OGG Vorbis format and ensure that 3D sound is disabled. It will play as a music track. And for the Magic Crystal sound, I'm going to leave this as a native WAV file because it's a very small and short track. And I'm going to disable 3D sound because this is also going to play in 2D, as it were. I'm going to choose the apply button. And there we have it. All of the assets for our project are now configured, and we're ready to move on. So now we've created our project, imported the assets, and we're almost ready to begin making our first level. I say almost because there's still one more thing that I would like to do regarding assets. Let's open up the meshes folder here and take a look at the environment meshes. Here we have, for example, a corner piece for our environment. Here we have, you can see, a door piece, and here we have a single floor piece, and here we have a single wall piece. Let me just drag and drop the corner piece here into the level and press F on the keyboard to focus on this. Actually, I'm going to change its position here, the position in the transform component, to 0, 0, 0 to center this, at the world origin. Now you can see that this piece here looks a kind of a dull, drab grey, and we know already from the textures section that we've imported environment textures for this mesh. I'm not going to be using the normal map in this course. I'm just going to be using both of these diffuse textures here, one for the environment and one for the props. Now the key, we need to create a material that we're going to be assigning to this object to get rid of this grey appearance. Now it comes with some materials already imported. If I go to the Meshes environment folder, you can see that it's already imported some default materials, but I don't want to use these. I want to create completely new materials for these objects. So I'm going to switch back to the assets root node here of the asset hierarchy, right click in the project panel and choose create and folder, and I'm going to name this folder materials like so and enter this folder. And I'm going to create a new material. Now the key to good performance when you're making games is to use as few materials as possible. So try to keep your materials to an absolute minimum, and that will help you boost render performance. When we created the assets for this game, if we have a look at the environment textures, you can see that all of the environment pieces were mapped into a single texture, which really helps us to reuse the same material across all of our objects. So I'm going to switch back to the materials folder here, right click and choose create and new material, and I'm just going to call this mapped env for environment. And over here in this panel for the shader type, I'm going to leave this as diffuse, a standard diffuse shader. We could of course click on this and change this to a different kind of shader, but I'm going to leave this at diffuse, and I'm going to leave the base RGB color to white. For the texture swatch, I'm going to click on the select button here and use this texture selector to select the environment texture, which is, here it is, the environment texture like so, and I've now loaded that in. I'm going to create a second texture, right click, create and select material from this context menu, and I'm going to choose matte, and I'm going to call this prop like so. So we've got the material for our props, and again here for the texture swatch, I'm going to select the prop textures, which you can find here, the prop textures. So I've loaded both of those in. Now of course to assign this environment material that we've created here, you can preview this in the preview panel of the object inspector, but to assign it to our object I'm just going to click and drag, and there straight away we've assigned this material to this environment piece. And again we can apply that to all the other environment pieces. For example, if I move back to the Meshes environment folder, I can drag and drop this door piece in here, I can drag and drop a floor piece, and also one of these single wall pieces. I can switch back to my materials folder and just drag and drop the environment texture onto all of these pieces. Let's maximize the scene viewport, and you can see that texture now applied and shared across all of these objects, and that is an efficient way to work. So next we're going to get started at building a level. So we're now ready to start building our first level, and if you go back to check at the beginning of this course where I demonstrated the project to you, you'll see that the first level is kind of a cross shape. So we have one area, one length of the level stretching across here, and another stretching across this way here. Now I've loaded these pieces into our level, so we've got one instance of each of the main mesh environment pieces. We have a floor section, a wall section, a door section, and a corner piece, and these four pieces are crucial. They form the foundation of our level, and I'm going to show you exactly how. We're going to be using the modular building method to construct our environment just on the basis of these pieces. So let's see how we're going to do that. Well, we know that for our cross-level environment map that we've got here, that we're going to be needing a corner piece for the end sections of the environment, and we can see that we've got this section here. Now of course I could just move this into a place that I like by just selecting it and just moving it absolutely anywhere, but you can see by the values here in the object inspector that really it's very difficult to precisely position this. So what I can do is use this gizmo here. I can use the arrows, and just by clicking on single arrows here I can constrain movement to just one dimension. For example, I could click on this red arrow, which is the x-axis. I know that's the x-axis because you can see in the key that we have here that red is marked as the x-axis, green is y, and blue is z. So I could constrain motion of this piece in the x-axis just by holding down that x-axis arrow there and clicking and dragging it. It doesn't matter where I move my mouse, the motion of this piece is just constrained to that axis. But you can see that by default, as I'm moving this piece here, you can see in the object inspector the x position values. They're not really changing in nice, neat increments of whole numbers. We're getting lots of decimal values here. In fact, if you look at the grid here, how this lines up with the grid, you can see, if I just zoom in a bit more, that when I translate this, we're moving not even by a whole cell increment, we're just moving it continuously. Now I can use snapping to constrain the movement even more to align to this grid. If I hold down the control key on a PC or the command key on a Mac, and then I can start moving these objects, you can see here that we're starting to constrain the movement of the object to nice, neat grid increments. And you can see here in the object inspector that these position values are really nice whole numbers. So sometimes I often want to use that when building a level. So what I'm going to do is I'm going to position the corner piece in the level to, let's say, about over here, for example. So here we have our corner piece. Now, of course, we need another piece for the other corner. This is fine, this is just one corner, but we need another piece over here for this corner. So how do we do that? Well, we could repeat this mesh adding process. I could go back to the meshes folder, back to the environment folder, drag and drop in this corner piece here. Again, go to the materials folder and drag and drop the environment material. I could do that, but that's really quite tedious and I don't want to do that. That's a lot of hassle. So I'm just going to select this piece and delete it from the level. Instead, I'm going to select this piece and I'm going to use duplication. So I'm just going to select this piece and press Ctrl D on the keyboard or Command D on a Mac, or I can also choose Edit and select Duplicate from the menu here. So I'm going to press Ctrl D, and when I do that, a new piece is added to the level. And if I move it away here, you can see now we've got two pieces. So again, I want another corner for the other side. So again, this is not rotated correctly. So now I want to rotate this piece. So I'm going to switch to E on the keyboard to switch to the rotate tool. And again, we get the same problem where I'm rotating on this axis, but it's not in nice, neat increments. You can see that from the object inspector here. I want to rotate this in nice, discrete increments. So again, I can hold down the control key on a PC or the command key on a Mac. And as I rotate, I'm rotating now in nice and discrete increments. And so here we've got, well, 89.9999. I'm just going to change that to -90 so that we've got this piece rotated exactly how we want it here. I'm going to maximize my scene view by pressing spacebar on the keyboard while the mouse is hovered over. So press space to maximize this here. Now I want to line this half up with this half to form a complete end section. And I want to do that nice and neatly at the vertices. I could just grab this piece, press the W key to switch to the transform tool, and I could just sort of constrain movement and line it up nicely until it's sort of roughly right. But you can see there's a small piece of overlap. I could in fact move it back this way, but then we get a small gap between the meshes. I can align these nice and precisely using vertex snapping. Now to do that, all I have to do is select this mesh piece, then I hold down V on the keyboard. And when I hold down V on the keyboard, you can see our gizmo now snaps to the vertices of this mesh. And what I can do is I can align this corner vertex with this corner vertex here. So let's just zoom in a little bit so I can see what I'm doing a bit better. I'm going to hold down the V key on the keyboard, move to this corner vertex here, click and drag my mouse to the corner vertex of this piece. And now I have vertex snapped these two pieces together and these align exactly. And now we've got one complete end piece. And that is looking pretty good. I'm liking how that's looking. So for example, if I wanted to line up this floor piece here with this piece of the floor, again, we can just bring this over, move this up a little bit, and we can bring in this vertex snapping technique. So I can hold down V on the keyboard, align this corner piece with the mesh piece here, and line this up nicely. Now, of course, I had to try and guess where that vertex was. I didn't see it very easily, and I can really improve the visibility of my meshes and vertex snapping when level building. I can move over here and select textured and change that to, for example, textured wire. And now we can start to see the structure of our meshes rendered on top of their textures. So I can get an idea for where the vertices in the meshes are, and that will help with vertex snapping. So there we've made a good start at building our level. Next we're going to be moving on and taking a look at prefabs. Now off screen, I've gone ahead and rearranged some of the pieces in our level to form this complete end section, and I've done that using only the techniques we've seen already of mesh duplication and vertex snapping. Let's just maximize the scene viewport and see what we have here. We have the end corner piece here, we have the other corner piece, and we saw how we vertex snap those together. We've also got two single floor tiles and two single wall sections here, and this forms a complete end section for the level. Now we know that because we're creating a cross section, we effectively want this end section repeated. So we want another one rotated on this side, another one here, and another one down here to form the complete cross section. And I want to show you how to do that using prefabs. Now of course we could make this other end section just by duplicating these pieces again and just rotating them into place. For example, I could select this section, press Ctrl D and just snap this over here. Again, rotate, snap this, bring this into position over here. Duplicate this piece, bring this out and rotate this in nice neat increments again. Vertex, snap this into place. Again, I've made another end section here, and we could repeat this for these meshes here as well, but we could be here all day doing that. That is a little bit tedious. There is another technique we can use called prefabs that can really help us build a level in a modular way. What it effectively allows us to do is select all of these meshes and say to Unity, hey, you see this configuration of meshes here? I want you to think of this as one complete and whole new mesh that we can just reuse, just like any other ordinary mesh. I want you to treat them all together as one. Well, we can do that really easily, and let me show you how. I'm just going to minimize this viewport here. And the first thing I'm going to do is just take any of these pieces. So I'm going to select this corner piece here, and I want to select all the others, and I want to make them a child of it. So I'm going to select them all, click and drag them. You can see my cursor changing, and I want to parent them beneath this top piece. So now if I expand it in the hierarchy, you can see there's a parent and child relationship going on where this mesh here is the parent of all the others. Notice that when I select this now, all of the other pieces are selected, and in fact when I move it, all the other meshes move with them. Now what I want to do is I want to template this and effectively tell Unity, treat this as a single mesh asset, and we can do that using prefabs. So I'm going to select the assets folder up here at the very top. I'm going to right click in the project panel and choose create and folder, and I'm going to name this folder prefabs like so, and just enter this folder here. I'm going to create a new prefab, and to do that I'm going to right click and choose create, and I'm going to select prefab, and I'm going to name this prefab, let's just call this end section like so. And all I have to do to complete the construction of this prefab is drag and drop this single object here, drag and drop that onto the prefab, and straight away it has created a mesh prefab. If I select this, you can see here in the object inspector in the preview panel, we now have a complete end section. And I can now just drag and drop this to add end sections to the level. We need one more end section like so, and now we have 4 complete end sections. Let's just arrange these at the origin. Let's just transform it over a bit. We're going to be just aligning these into place. Let's select this one like so. Okay, so now we have our end pieces. Let's just maximize the viewport and just start to rotate these into place. Actually, I want to rotate this one around the y-axis, so I'm going to just rotate this to 0. There we have one end section. I'm going to rotate this one, let's see, to about this side, so that's going to be probably negative 180, one there, which is going to be for this end. And this piece here, which I'm going to rotate to, let's see where that should be. Press E on the keyboard, rotate it around. It looks like it should be about 90 degrees. So move this over here. And now we've got the 4 end sections that we need to create our cross environment. All we need to do now is to piece together the center section. So to do that, I'm just going to be reusing the single floor piece. So let's just come in here, duplicate that. Just move that out here. You can see I've got this floor section, but it's parented beneath this object because I duplicated it from this, which was already a child. So I'm just going to drag and drop this out of that hierarchy, and I'm going to just start to vertex snap this back to this edge here. So hold down the V key, move that into place, Control D, duplicate that there, vertex snap this, Actually, I don't think that's quite vertex snapped correctly. No, it hasn't. I've vertex snapped the wrong vertices there. So let's just select these two. Again, duplicate them, pull them out here, and again, vertex snap these back into here. And now what I can do is to start to vertex snap these edge sections into place. So again, I'm going to put V here, snap that into place there. That's looking correct. Again, vertex snap that into place there. And finally, this one, select this and vertex snap that into place there. And there we have one complete cross-section environment, and things are looking good. But you will notice that there are some problems. For example, we don't really have a nice arrangement of the geometry on these outward turn corners here. We don't have a dedicated outward turn piece to disguise these seams that we're getting here in the meshes. And we're going to be looking at how to conceal these seams using props in the next movie. So here you'll notice that we have these outward turn sections where there are breakages and disconnections in the meshes where the vertices don't line up. And this is really quite apparent in our level that we have here. Now ideally, when modeling your own environment modular pieces, you can, or you will, model them so that the seams here are not apparent and the vertices and the meshes line up nicely. But sometimes you might be working with assets, as in this case, where we don't always have enough pieces to create these seamless sections. And so then you have to go about finding inventive solutions to disguise these problems. Now before going ahead and repairing this, I find that the view or the display here in this scene viewport is quite dark, and what I want to do is brighten it up a little bit without using lights so that I can just see what I'm doing just a little bit better. And I'm going to be doing that by using ambient light. So I'm going to press space to exit the scene viewport. I'm going to move up here to the menu and choose Edit and choose Render Settings. And in the Object Inspector you can see we have an ambient light field here. So I'm going to click in that, and I'm going to change the color from this medium gray to something closer to white here, and just exit that. You'll notice there's no change in the scene viewport at all, and that's because the lighting feature has been disabled. You'll see that there's a lighting icon here. I'm going to click on this lighting icon, and suddenly our viewport is now illuminated with that ambient light. If I just tone that down, you can see it's changing the illumination of the level. So I'm going to enable this ambient light, and just so we can see what we're doing a little bit better. And now let's get started at trying to disguise these edge pieces. To do that, I'm going to be using one of our props. In fact, if I move over here to the Assets panel and I move over to the Meshes and I choose Props, you can see that we've got this pillar piece here, and I'm going to be using this pillar piece to disguise these edges. So I'll drag and drop the pillar piece into the level, which you can see here, and let's just raise it up a little bit. Let's just maximize the scene viewport so I can see it better. So I'm going to raise it up just so that it's touching on the ground surface there. You'll notice that it has no material applied. We can easily fix that by just going back to our materials folder, dragging and dropping the matte prop onto that pillar, and you can see right now that we've got a nice grey stone-like texture on that pillar. So what I'm going to do is I'm just going to move this pillar over to this wall area here. Just move this into place like so. And what I want to do is just position this so that the wall is not penetrating through the pillar. So just move it over here just a little bit. And there now we have a nice pillar section. And I want to just really repeat this process for these other corners. So to do that, I'm going to switch to a top view by clicking on this Y arrow here to switch to a top view. I want to change the view from this perspective look to an orthographic look, like so, just by clicking on that white box in the center. So now we have a truly orthographic view. I'm going to press Ctrl D to duplicate the pillar, and I'm just going to drag it over to this side so that we create something similar over there. Select both of these, press Ctrl D, and then just drag these down to these other corners here. Now I'm going to switch back to the level just by rotating around, but you can see the view is slightly different, and that's because it's an isometric view. I can just change it back to perspective just by clicking on this white box again, and we go back to the perspective view. So let's just check and inspect these pillars to make sure they're appearing correctly. Again, we've got some penetration there going on, so let's just move that over this side, and well, the same for this case. So let's just move this into place here. Move this into place here, And again, here as well, we've got some issues to resolve, like so. And then that's looking pretty good. I may off screen go ahead and start to put some of these pillars on these outward edge pieces here for some consistency. But one last thing that I wanted to mention was about these walls. This is an isometric kind of a third-person view game, which means that our view is going to be up here somewhere. It's not a first-person view. Now, because of that, we're actually going to be able to see through these wall pieces here, and I don't really want that. I want these walls to look like solid objects. So I'm going to need to put some wall sections on the outside of the level here. Now, to do that, all I'm going to do really is just select, for example, this wall piece, and you can see that's selected here in the hierarchy panel. I'm going to press Ctrl D to duplicate that and create a new instance and drag and drop that out just to unparent it. And now I'm going to go back to the level here, switch to the rotate tool and just discrete rotate that around like so. Let's just bring this out here, and I'm just going to scale this in so it's really quite thin. I'm just going to scale it on the red or the X axis non-uniformly so that it's pretty slim, maybe a bit thicker than that perhaps. Something like that, and then switch to the translate tool and then just vertex snap that here to create a kind of a back face for that area. And I'm going to duplicate this again and move this outwards and just vertex snap that into position there. So what we've created is a kind of back face for that region, so it looks nice on both sides. And off screen I'm going to repeat that process for all the other sides to assemble a completed level. Now off screen I've gone ahead and added some pillars to the edge or the corners of these sections here in the level, and I've also added some mesh pieces, the wall pieces, to the outside of the environment so that it looks good from both sides. And you can see all of those mesh pieces represented here in the hierarchy panel. Now the next thing I'd like to do is to introduce some organization into my project concerning game objects and their hierarchical arrangement. So I'm going to do that now. I'm going to add a new game object to the scene by choosing Game Object, Create Empty, or I can press Ctrl-Shift-N on the keyboard. That will add a new game object to the scene, and I'm just going to name this game object ENV for Environment. I'm going to reset its transform properties, and I can do that quite easily by clicking on the cog icon here, and it's probably outside the recording window, but there is a button at the top which says Reset. I'm going to click that button and all the transform here is zeroed out to its initial values with the scale of 1, 1, 1 on each axis. That's fine, so this empty game object is now here centered at the world origin. This is going to be the root game object for all of the environment pieces. So what I'm going to do now is move over to the hierarchy panel and select all of these end section pieces and parent them to the new ENV game object. And the same for all of these other mesh pieces. So I'm going to select all of these and just parent them to this game object, leaving only the main camera object outside. So now if I select the ENV node, I could, if I wanted to, move the whole environment in just one operation, which is pretty handy. I'm now going to create another game object create empty, and I'm going to name this one root, and I'm going to reset the transform properties again. And I'm going to just parent everything to that root. The root is the game object, the ultimate ancestor object of absolutely everything. And that kind of tidies up the game object arrangement. Now the next thing I want to consider is the issue of lighting. Now the main source of illumination in this level is going to be created from fiery torches that are going to be on the walls here. Now these fiery torches are going to be created later in the course using the shuriken particle system. But what we're going to do now is to add some lights to the level to approximate those torches, and we may need to come back later in the course and just tweak the lighting. But I want to show you now how to configure the lighting so that you understand how the process works, and you can tweak it later if you want to. Now the first thing I do before getting started with any lighting is to completely disable the ambient light in the scene, because a level without any lights should appear completely black. So let's do that now by choosing Edit and then Render Settings, and the ambient light which we tweaked earlier, now I'm going to set that to completely black to make our level completely dark. So I'm going to add our first light to the scene by choosing Game Object, Create Other, and I'm going to add a point light to the scene, which you can see here is added at the origin. It's still quite dark, but what I'm going to do is just raise that up into the scene at roughly the level that the torches will appear, so somewhere around there. And I'm just going to pull the light into here, move it over just a little bit, just maximize my viewport here, get the settings that I want. So maybe somewhere about there, that's looking okay. What I'm going to do is I'm just going to reduce the range a little bit. It's really quite an intense range. It's quite a large range here. I can do that by tweaking the range parameter here in the object inspector, or I can just bring in these values to maybe something like this. And I'm just going to increase the intensity of the light, maybe to somewhere around there. And I'm going to change the color of the light from plain white to maybe something that's closer to an orangey color, maybe something like that. I may just increase the range just a little bit here, tweak it a bit more, something like that. Maybe just increase the intensity a bit more. I need to leave it like something around those lines. So I'm pretty happy with how that's looking, and what I'm going to do now is use the duplicate procedure that we've seen before. So let's maximize the scene viewport, select that light and press Ctrl D on the keyboard and bring it over to this side. Ctrl D again and bring it over to there, something like that. Ctrl D again to bring it over to that side, around about there. And I think that we can probably settle on that kind of arrangement here. Remember, we're going to be baking in this lighting into the level. We'll see that later on. It might be a little bit darker than we really want, but that's okay. It will brighten up a bit later, and I'll show you how. So that's pretty good for a kind of basic lighting arrangement. I'm going to group these lights together. So I'm going to select Game Object, Create Empty. I'm going to name this object Lights. And again, I'm going to reset the transform and parent the light object to the environment object here. And again, I'm going to parent the lights to that object. So now we've grouped the lights together in the scene. So that's looking pretty good. Actually, I think what I'll do is unparent the lights from the environment and make them under the root object. So just bring them over here like so. So now we can close up the environment and we've got the lights on a separate group there like so. So that's looking pretty good, and that's the basic lighting setup that we're going to be using for this level. Next, let's consider the issue of baking lighting using light mapping. In the preceding movie, we added lighting to this level through these 4 point lights that you can see at the 4 edges of our level. And it's looking pretty good. But if we press the play button on the toolbar, these 4 lights will be calculated in real time. That means that Unity will calculate the effects of these lights while the game is running. Now, lighting calculations are very expensive and we should try to minimize them wherever possible. One little trick that we can do for objects that don't move is that we can save or bake the lighting information into their textures. Now, we know that these walls, these pillars and these floors, they will never move while the game is running. They're always stationary and in place. These kind of objects are called static objects. And with these, we can perform what is known as light mapping, which is where Unity will generate textures for these objects, known as light maps, that will save the lighting information into the textures. At runtime, when the person plays the game, they'll never know the difference between this real-time calculation or the lighting baked into the textures. And that's what we want to do now. So let's get started with light mapping. Now, before we can go ahead and perform the process of light mapping, there are some preliminary steps that we need to take to prepare our scene. In particular, we need to mark these objects as static. Right now they exist in the scene, but we need to explicitly tell Unity that these objects will never move. So to do that, I'm going to just come out of the scene viewport here and move over to the environment group. I'm going to select that, and you can see that all the environment objects are now selected in the scene. You will see up here that we have a static checkbox. In fact, I can click on the drop down and there's a whole list of things that we can select from that. But I'm going to ignore that list for the moment. What I'm going to do is I'm going to put a tick inside this static checkbox. And when I do that, we get prompted here for this question. Do you want to enable the static flags for all the child objects as well? So do I want to enable this static flag for this object, environment, and all its children? Well, yes, I do. I want to say that all these objects in the scene will never move. They are static. So I'm going to choose yes, change children. And now this has been enabled for all those objects. I can check that if I like. I can expand the environment group, select this one, and oh look, static checkbox is checked. And the same for all of its children. It cascades downwards through the hierarchy. So now we've enabled static for all of these environment pieces, and this allows us to go ahead and calculate light mapping for the level. So what I'm going to do this now is switch over to the light mapping tab, and if you don't have the light mapping tab open, you can always open it by choosing window and light mapping. So I'm going to switch to the light mapping tab that I've docked here into the object inspector, and we get the light mapping controls that come up here, and so we've got all these settings that we can use. Now mainly what I want to pay careful attention to is to this bake tab here. So we've got a whole range of settings on this bake tab, and we're going to be considering what these do next. So now I want to go into the issue of light mapping in more depth. I've got my scene open here with the light mapping tab open on the bake section, and the first thing I want to do is set the mode for the light mapping. So what's going to happen here is we have some options: single light maps, dual light maps, and directional light maps. I'm going to be choosing single light maps. Single light maps work both with the free and professional versions of Unity. The exact details of what the other options are, dual and directional, I'm not going to go into in this course, but the single light maps, what this effectively does is it calculates all the lighting in the level, both the direct and the indirect illumination, and it saves them all into textures that it applies to all the static geometry in the level. That is what single light maps do. So I'm just going to scroll down, and of particular importance is this resolution field, and I'm going to be returning to this very shortly, but right now I'm just going to turn that down to say a value of 10 for right now. We're going to be tweaking this a bit later as I explain what it does, but for now let's just choose the value of 10, or even less if you want. And then I'm going to choose Bake Scene, and what clicking Bake Scene will do is it will generate a light map texture that applies to the level. So let me just click Bake Scene, and now this process, baking the scene, can actually take quite a long time. If your level is very large and your resolution field here is very high, it can take a long time, but notice for us, that's it, it's really quick. Right now you'll see in the preview panel that it's already generated a texture for us. Here we've got this one texture that has been generated under this group called Far. You can see here it's generated one single light map, 1024 by 1024, 2.7 megabytes in space, and this now has been applied to our level. Now everything is looking okay here. Actually it's looking a lot better than I thought it would do, even though everything is not quite as it should be. So right now let's just take a look. I could select, for example, these lights in the level, like so, and I could delete them first of all, and you'll notice that the level remains illuminated, and that just goes to show us that the reason it's illuminated is not because of those lights. It is now because that lighting information is baked into the level. So I'm going to press Ctrl Z to undo that, like so. Now there is actually a problem with the level, but unfortunately it's not entirely apparent because the light mapping here is not looking too bad at all. But one setting that we do need to change, if I just switch back to the inspector and I move over to our meshes tab and select the environment meshes, we do need to enable this option here which says generate light map UVs. What this does is it allows Unity to automatically generate UV information for our objects to save our light maps properly. So make sure that you enable this option for all these meshes. I'm just going to enable a tick down there and then choose apply on this toolbar. Now notice however that when I did that, the light mapping for our level completely changed because I changed the UVs of the mesh pieces. We will now need to go in and rebake our light mapping. But that's quite easy to do. I can just move back to the light mapping tab. I can even choose clear, and what that will do is it will erase the light maps and return back to using dynamic lighting, and I can prove that by just selecting one light in the scene, moving it out there, and notice that becomes darker because it's being controlled now not by the light mapping but by the light itself. So I'm going to press Ctrl Z to undo that, and I'm going to rebake the light mapping with these same settings by choosing Bake Scene, like so. And now again it starts exporting. Down here shortly we'll notice a progress bar indicating the progress of the calculations, and voila, now it's baked a new light map. Again, still one map here, one single light map, 1024 by 1024, and actually it saves these light maps as textures in the project assets. I can choose assets, I can choose scenes, and notice there's a folder here, scene 00. If I go inside there, you'll see, aha, here is the light map texture that we're using. I can go to the inspector panel and see more information. Notice the texture type is a light map. So this is the light map information for the level. Okay, so that's the basics of getting started with light mapping. In the next movie, we're going to consider it even further. Now in this video, what I want to do is to focus more attention on this very critical parameter, resolution, and on how it relates to the geometry in the scene and the size of the light map texture that is generated. So what we have here is when this light mapping window is active, we can see this light map display dialog in the bottom right hand side of the viewport. If I switch to the object inspector, you can see that we don't get that dialog. It's only available when I switch to the light mapping tab, as I have here. And what I want to do is to enable this dialog here that says show resolution. Just put a tick in that checkbox, and when I do that you will see that the whole of the scene geometry is patterned with this checker pattern here, which is a UV grid. Now what this is showing us is the texel density of the light map texture that's going to be generated. Each and every one of these squares in this pattern represents 1 pixel in this light map texture that is generated. So if I reduce this value to a size, the resolution value here, to a size of around 2, which means 2 pixels or texels for every world unit in the scene, what this is showing me is a new grid. And again, each of the squares represents 1 pixel. It's saying that if you generate a light map texture now using the Bake Scene button, what you will end up with is one of these textures where 1 pixel stretches over this amount of space. So all of this texture here will hold the lighting information for the level. But of course, at this resolution, the texture might look a little bit blurry. So I'm going to want to increase the resolution. Now right now you can see here we've got a lot of wasted space in this texture. We had a setting of 10 texels per world unit, which was the one that we had here. But given the size of our level and the size of the light map, most of the information is squished around this edge of the texture. So generally the idea is to have this value as high as possible without generating more light map textures, being able to squeeze as much data as you can onto a single light map texture. So I'm going to increase this field to say, about maybe 40, like so, and now I'm going to choose Bake Scene. Now the higher this value, probably the longer that we have to wait. So let's take a look at this first of all and choose Bake Scene. So here we are now, the scene has been baked with a resolution of 40, and you can see we're using a lot more space in that light map texture now, where a lot more of the area of the texture is being covered by valid data. So let me just disable the show resolution checkmark, and you can see that the lighting in our level is looking pretty good. But I want to still tweak this a little bit further by using some of these other settings that we have here, particularly bounces, bounce boost, intensity, and ambient occlusion. And we're going to be considering these next. So what I want to do now is to consider the remaining settings for light mapping to produce the final light maps for the level. In particular, I want to consider the settings of bounce boost, bounce intensity, and ambient occlusion. Now a lot of these settings are available only in the Unity Pro version, which means that if you have the free version you will not be able to follow along with me, and you will more or less have to consider the light mapping done already. But if you do have the professional version, then you can follow along with me. So the first thing I want to consider is bounce boost and bounce intensity, and this refers to the strength and intensity of the indirect illumination in the level. That is, when any light source, such as this light source, emits rays of light into the scene, those rays strike surfaces and bounce off of them and continue to illuminate other areas. This is called indirect illumination. Now we can increase the number of bounces directly by changing this bounces setting, but I find a value of 1 usually works fine. we can use the bounce boost to kind of artificially increase the number of rays without getting that expense of adding more here. And we can also increase bounce intensity to increase the strength of those rays. So what I'm going to do is I'm going to increase both of these settings, and it will have the effect of brightening up the level a little bit more. Now I'm also going to enable ambient occlusion by switching it straight over to 1 here, and I'm going to increase the contrast. Now ambient occlusion refers essentially to contact shadows. That is, in the areas where different mesh pieces meet, such as where the floor meets the wall, there will be some darkening around these edges because less light can reach them. And that would apply to any other areas, such as where the pillars meet the walls and so on. So we add contact shadows. So I'm going to increase the contrast here just to make those effects a little more prominent. And I'm going to accept these settings more or less as they are. Make sure the resolution is set to 40 and that it's set to single light maps. So I'm happy with those settings, and now I'm going to choose Bake Scene. Now with those settings applied and tweaked, I've got a scene here that's a little bit brighter and has some ambient occlusion effects near the edges here. You can see some of the results of that darkening. So we have a scene here that's looking pretty good now, and things are set up just as I like them. What I'm going to do is, off screen, I'm going to apply these level design practices, creating prefabs, arranging these elements, and creating the light mapping to produce the second level for our game, so that we have both level 1 and level 2. And I'll resume recording in the next video when both of those are created and I can show them to you. So off screen, I've gone ahead and created both levels for our project here. Scene 00, which is the level that you see in front of you, and also Scene 01, which is the second level. And in creating these levels, I've used nothing more than what I've shown you already, using vertex snapping, transform snapping, and light mapping, as well as prefabs. So here is the first level, the cross-shaped level that we have seen already. And if I double click on Scene 01, which is the second level, you can see the second level that I have built here. Let me just maximize the scene viewport to show you this level. We have this area of the level here, which is where the destination points for the boxes are going to be placed, and the boxes themselves are going to be starting from these positions down here. We're going to be adding those features later in the course. But right now I've just arranged this level. You'll notice on the outside I've created some props, including a table and the bookcases, and I've also gone ahead and light mapped this level. If I come out of this and go to the Scene 01 folder here, you'll see the light map that I have created here in the preview panel. Now if I move over here to the prefabs folder, you'll see some of the prefabs that I've created in assembling this level. For example, I can select this sort of quad piece here, which you can see in the preview panel, which refers to these meshes here, these sort of block sections that are going to be used as obstacles when pushing the boxes. I can just drag and drop those into the scene and use them like any regular meshes, and they were really very helpful to me in assembling this level, so that I didn't have to sort of assemble all these pillars and these other individual pieces together. I could just reuse them from the prefab. So right now this project that we've created so far is included in the course companion files. You can open this up and inspect it for yourself, and this really represents the end of the first volume, and it's a great starting point for our project. Next up, in the second volume, we're going to be considering the issue of character animation, inverse kinematics, and player controls. And really, we're going to start to bring this project alive. So this is a great starting point, and thank you for joining me. This has been 3D Motive. I hope to see you in the second part.